All right, AP Physics. Welcome to week 2 of online instruction. I know that if you watched the other video and you made your way here that you probably already got some of this information or got welcomed, but either way, no big deal. So we're going to talk about simple harmonic motion again this week. One of the things that we now know is that the test is only going to be free response questions, but we do want some practice. This is why I had you start on the multiple choice. A good portion of you did not start on the multiple choice, so I will have to call you today. Today's Monday the 6th. So I have to give you a call because the school requires me to if you haven't done anything week 1. So I actually have to call your parents and be like, hey, your student hasn't done anything. It's a requirement, so just understand that you're going to hear from me and you're going to hear from all of your teachers if you didn't do anything week 1. So again, about half of you guys didn't start the questions last week, so just make sure you do that. Yeah, so that's kind of where I want to start at, was just on AP Central. I don't know if you're having a hard time getting in. I know a few of you have been. If you've talked to me about having a hard time getting into AP Central, then that counts in terms of like making contact with me week 1. So don't worry about that. You need to try to work your way through it. But yeah, so our test day is now changed to Thursday, May 14th. So that's actually an entire extra week for us. We only have this subject and torque to cover, and then we'll start doing some reviews. So I honestly think that we're in a really good spot, depending on what it is that you want to put into it or get out of it. Yes, I know that you could have just clicked through every one in the multiple choice and just been like, hey, I did that. That's really on you to see what you do or don't want in terms of like your preparation. Same thing with questions. You need to make sure not only are you doing them, but that you're looking out for like indicators on what is the test kind of pointing out to you is important, and what do you need from me? Like what kind of information are you not getting or do you not understand? I recommended some videos for you guys in the course webpage last week. If you looked in there, I would say that you should have watched the flipping physics videos on simple harmonic motion. If you didn't, you're probably behind the curve. So just try to follow up with those. There is a Khan Academy video on vertical springs that I also asked you to watch for me. And I would say that that's a really helpful video in understanding like why didn't we have to worry about gravity when we're talking about it. And it's pretty good. I'll say that the multiple choice questions, question 1, I thought was stupid, bad, terrible question. And their answer, actually, the way that they present it doesn't make sense. They literally do bad math. They're like, oh, you have to square this and FOIL it, and then they FOIL it wrong in their own description. They literally just do it wrong. So questions that you have about that, we can kind of try to cover it, but you need to let me know what you need. So you'll see that we have a new assignment this week. There's a couple of questions that I want you to look at conceptually as well on top of the free response question on AP Central. So just make sure you're doing that. For a lot of you, yes, you also have to catch up with the multiple choice. So just make sure that you are doing that. Cool. So yeah, did you watch the videos? Are you watching my videos? Is there anything I can do to help you out there? And just kind of make sure you're there. We talked about this. It's in the school webpage, but again, I don't know if you can see that. I assume that it's easy for you to see, but I don't know this. But we do have a meeting on Wednesday, and I'm going to be giving videos answering your questions on Wednesdays. So really, it's in your best interest, as quick as you can, right, as early as possible, to go through the material and find things that are confusing you. You don't have to cover everything. Obviously, I understand time limits on what you can spend in front of the computer every day. I have the same time limits, right? But just make sure that you are taking the time to actually go through and look at these things so that you can ask me these questions so that I can put them in my video. So I'll record a video that just kind of explains some things that you guys have asked me about every Wednesday. I'm not going to make an hour-and-a-half long video, so just know that I'm only going to get to certain levels of questions. Ideally, if I get everyone in the class asking me the same questions, I'll go through it that way. So just make sure you try to keep up with that. So I just banged my ankle. We're 4 minutes into a video that I've already recorded all the information I wanted to, so I'm not going to restart it. So you just get to see that. I just banged my ankle, and you just get to deal with it. Yeah, so just let me know any questions or concerns that you have. Right. So really quickly, I now have a little whiteboard, and I'm going to start talking about some stuff with simple harmonic motion for you guys, things that you really are the main idea to keep track of. Honestly, this kind of works both ways. The idea with simple harmonic motion is that we have to have some sort of restoring force that is equal or is proportional, directly proportional, and in the exact opposite direction of whatever force I'm putting on it. So like when we have a spring, when I pull it back, we know that we get the Hooke's law of spring force, right? And so we know that it's coming back the exact opposite direction, and that whatever I pull on it, I'm probably getting the same force back the other direction, right? So that's the main idea behind what simple harmonic motion is for the most part. So again, you have to have this restoring force. It has to be directly proportional to the displacement, right? So that's one of the reasons why pendulums don't represent simple harmonic motion outside of 15 degrees. So if you were to pull this pendulum all the way back, so let's say that we have a pendulum, right? We've got a weight on the end of a string. And let's say that we pull it back and that this angle is only 10 degrees, right? Oh, that's going to be reversed. I don't know how to do that. I'm not going to do it opposite. I got to figure out a way to do that, don't I? Because I'm not going to do everything backwards. Anyways, I guess I won't put the angle in there for now. It doesn't really matter. But here, this restoring force is going to be exactly proportional and opposite to the direction in which it's displaced. But if you get a higher angle than that, let's say again that was 10 degrees, let's say that you pull this thing back further, if you were to do that, it's no longer going to be that same proportional relationship. With the spring, it is, because you don't have this angle, right? And you don't have this gravitational force that changes as you move this thing up and down. But with pendulums, you are going to have this change in gravitational force as you pull this thing further and further back. So that restoring force is no longer directly proportional to the displacement. And that's a big deal. So again, the thing that we do know with spring energy or spring forces is they are directly tied to how far back I pull back the unit or whatever it might be. And again, with pendulums, because you have this angle and you have this changing gravitational force based on how far back or how far up or down this thing has been moved, right? Then you're going to get this non-proportional relationship there. So that's one of the things, if you've gone through and noticed when they're talking about these pendulums, they're trying to make them all small angles, and that's the reason why. If you watch the videos, they probably covered that pretty well. But the main thing being that we're going to have with anything that's simple harmonic motion, it's going to be, we're going to pull something back from an equilibrium position. It's going to come back to that equilibrium position. Because it has velocity, it's going to continue through it. There is now all of a sudden another restoring force, and this restoring force again is directly proportional to our displacement. And so it's going to keep doing that over and over and over again. And in a situation where we don't have friction, and we're not losing energy to heat, which are not real scenarios, but they're scenarios that we would construct here, then you're going to have this motion just go over and over and over again. And that's where we have these equations for these periods that are based on different qualities, right? So for instance, with the spring, it has to do with the mass that's on the spring and the K of the spring. And they tell me how far back and forth this thing, or how long it's going to take for this thing to go back and forth and repeat its cycle over and over again, right? And then we have the same thing for a period with pendulum, but the pendulum is based on the length of the rope and on G at your given location, right? Because we use G as 9.8 or sometimes 10, but we know that G being 9.8 is at sea level and does change, right? And even then it's an estimation. It's really 9.80655 or something like that. But the point being that it's not exactly 9.8 everywhere. So we do know that that's going to change based on location. So then you're going to have this kind of regular motion that kind of goes back and forth. Now, one of the things to make sure you note is that, let's say we do have a spring, right? I'm going to draw a spring. So we have a spring, and let's say it's attached to the wall. And let's say that it's got a mass on it. And let's say that right here is the equilibrium position. I know that's going to be backwards, but that's fine. So that's going to be the equilibrium position. So in other words, we haven't stretched it. It's not doing anything. So when we stretch this thing out, let's say this far, now all of a sudden, again, we're going to have this restoring force that's going to be related to how far back I've pulled this thing, right? And so because of that, it's going to want to go back the other direction. Well, at its maximum amplitude, it's going to have only spring energy. So we have here just US. Cool. So when I let this thing go here, it has its maximum force and it has its maximum spring energy. And I know that's backwards. We'll figure that out. It's not a big deal. Has its maximum spring energy, right? And that's because it is at its furthest displacement, and that force is related to its displacement, right? So as I get closer to the equilibrium position, I have no displacement away from the equilibrium position, so I can't have any more spring force. At the equilibrium position, I have only kinetic energy, right? And I'll write K. And that is because, again, I now am, all of my spring energy has gone into moving, right? I'm at my maximum possible speed. So the vast majority of the questions that you're going to see in this section are going to be related to that basic idea, that your spring energy is going to be completely at its maximum at the maximum amplitude, which you'll call capital A. You'll see that a lot. And that is because, again, I've met my maximum displacement. My force, my spring force is related to my displacement. My spring energy is related to my displacement. And so, again, my acceleration is related to my force. So all of those things are going to be at their maximum at my maximum displacement, or my maximum distance away. And that means that as I move in, that force is going to go down. It will change. It'll be variable. So about some point halfway down, I'll have half spring energy and half kinetic energy. And that spring energy will keep turning into kinetic energy because I'll have my motion. So when I get to the equilibrium point, I no longer have this displacement. So therefore, I no longer have this restoring force, but I do still have velocity. So it's going to carry me through that equilibrium position. And then all of a sudden, I have a new restoring force. So we go back and forth and back and forth and back and forth. So honestly, the things that you're looking out for is that basic idea and the idea that you can't have negative spring energy, right? You just can't have negative spring energy. So if we take a look at it like a graph of our spring energy, it will oscillate, but it will always stay in the positive. Same thing with our kinetic energy. We either have kinetic energy or we don't, but we don't have negative kinetic energy. So both of them are going to have this same sort of graph where they're always positive. Yes, they'll oscillate from whatever their maximum is down to 0, but they'll never go below 0. So that's another thing to look at, right? So that idea, how do I relate my spring energy and my spring force, which relates to my kinetic energy, right? And again, remember, your spring force the force has to be directly proportional to your displacement. And they are, right? F equals negative kx. Well, that's directly proportional there, right? And then, again, we have that our maximum spring force is at that level. Our maximum acceleration is there because we're at our maximum force and they're related. And our maximum spring energy is, again, at that displacement. We come down to maximum kinetic, and then we kind of switch back and forth between the two. The other main ideas are just making sure you understand those period equations. Not only what does the period mean, what do the symbols mean, but how do you relate that to frequency, which is literally just 1 over that number. Is going to be your frequency. How often do we do this is your period. How long does it take, or I guess I should say, how long does it take for me to do this once is your period. How often do I do this is your frequency. How many times a second does this repeat itself, right? So frequency is recorded in a thing called hertz, which is like Hz. And that's, again, another thing to make sure that we take a look at. It's just how often do I repeat that? And that's pretty simply what it is. There's not like another way to describe that. There's no real... it's just how long does this take? How many times do I do this, and how long does it take for me to do it? So you can see how those two things are related. They're kind of like opposite sides of the same coin, right? So yeah, make sure we understand what those symbols mean. That would be the thing that I would suggest most to you on all of these things, is just really look at the equations that they give you and break down, can you understand what each piece means? And if you can do that, most of the AP test is going to be about recognition of how do I derive the things they're giving me. And having looked at the FRQs, you probably know that a lot of it is, can I identify how do I manipulate to get this variable? That's a lot of what the experimental design is. Do I understand how I would measure each of the variables I don't have to get to the one that I need? So for instance, in this chapter, if they're talking about how do you find the period of an object or manipulate the period of an object, well, you have to know, for instance, that 2 pi is obviously the radius of a circle, but that doesn't help us out here. But that, like, L for a pendulum means the length of the rope that the mass is attached to, right? And right now we're assuming the length of the rope is massless, which is inappropriate, but we're going to do that for simplicity's sake. And that G is 9.8, right? You can use 10 on the test, I believe, but it's really not going to be a lot of math-specific stuff on the test. It's going to be a lot of, like, concept recognition. So that's my brief overview of this section. Please reach out to me with any questions that you might have. I have not heard from any of you regarding anything on the material, and we haven't discussed this, right? So I know that you got my notes. I know that you've watched the videos, or hope that you're watching the videos. Just give me any questions that you might have between here and Wednesday. I'll record another video kind of going through this, and just kind of let me know what it is that you feel like you need or don't need, and if this is helpful for you. Okay, so I appreciate that, guys. This is again AP Physics Week 2. So thanks, and I can't wait to hear from you guys.